Hello and welcome. In this short video, I will talk about how we can calculate the round-off errors in Python. We will consider errors in divisions of integers. In the computer, a ratio of integers is stored in floating point format with double precision. This causes a round-off error in the computer, and as defined is the IEEE standard. We will show how we can calculate this error in Python. As an example, we will find the error of the representation of 1/3, also written FL of 1/3, which means floating point of 1/3. The error is defined as the exact value minus the computed value, which we have here, 1/3 minus FL of 1/3. We store this number 1/3 in a variable called 1/3. And now you see that 1/3 is written here as 1/0 and a lot of threes. So now the result is actually stored in the computer, and we'll talk about how this is stored. We have the sign, which in this case is positive, and we only use 1 bit to save the sign. And then we have the exponent that is also an integer. So it's a 2 in the power of some integer. And then the mantissa is given by n, a whole number 2, divided by 2 in the power of 52. So you can extract the ratio of a floating point number by using the Python function as integer ratio. So let us try that and store it in the variable myRatio. And you see, you get n and m, which are quite large integers. So finally, we will calculate the error. We could, of course, try to find the difference between n over m and 1/3, which actually should give us the error. But in the calculation, what do you think? Well, in the calculation, 1/3 will be stored exactly like this number. So the result is 0, and that's a false result. So we need to compare the exact value, which is 1/3, with n over m, which now is stored as n over m. So we got n here, and we got m there from myRatio, and myRatio was 1/3 and a dot as integer ratio, which is a function in Python that gives us the ratio, the exact ratio of the number. So in our case, we use this formula for the difference of two fractions. That should be very known to you. It's not very difficult. And we can calculate the difference from this. And the result is here. The error you see is quite small. And we can investigate this error. And you see, if we multiply the error with 2 in the power of 56, we get the following: 1.333, etc. And the floating point representation actually must have the exponent equal to minus 56, as we can see here, 1.333333, etc., which is a mantissa. Do not remember how many threes I put there, and multiply by 2 in the power, and power is double star in Python, and it's minus 56. And we see, do we get the same number? And yes, we did. This is the error. So thank you very much, and enjoy Python.